Hello and welcome back. Today we're going to be looking at how to simplify rational expression. So we'll start off with an easy rational expression. Let's take the rational expression 14x over 7. And we want to simplify this. Well, what we can do here, if we think back to middle school, let's say we had the problem 2 over 6. You guys should know how to simplify 2 over 6. That reduces down to 1/3. One way you can think about this is 2 over 6. You can think of as 2 as 2 times 1, and 6 as 2 times 3. The reason it reduces down to 1/3 is because the top and the bottom are written as products. You can only cancel factors that are alike. So if you get the top, the numerator written as factors, and the bottom written as factors, any that have in common, you can mark them out. Since they both have a factor of 2, we can cross out the 2's, and we just end up with 1/3. So I want to do the same thing with 14x over 7. Well, 7 is a prime number, so really 7 is like just 7 times 1. But you could rewrite 14x as 7 times 2x. So what factors do they have in common? 7. So 14x over 7 reduces down to just 2x over 1, or just 2x. So the only way you're going to be able to cancel things out from the top and bottom is if they have a common factor. So let's try another example. Let's look at 6x over 9x squared. Well, I like to just do the numbers separate and then do the letters. If we look at the numbers 6 and 9, do they have any common factors? 3. Because 6 is the same as 2 times 3, and 9 is 3 times 3. So we can mark out one of the 3's, and we'll end up with 2 over 30, 2/3. But now, let's look at the x's. On top we got x, on the bottom we got x squared. Well, x is just x. X squared is x times x. So how many x's do they have in common? 1x. So we can mark out 1x. So what do we have left over? We have an x left over on the bottom. So my answer is just 2 over 3x. Now it's reduced. All right, so let's try another one. Let's look at this. 2x over 2x plus 10. Well, if you want to cancel things out, you have to have things written as factors. Or 2x, we could write 2x as 2x times 1. The bottom is not written as factors. It's written as a sum. We got 2x plus 5. But if we want to write it as factors, what can we do? We can factor out a 2. I can think of this as 2 times the quantity x plus 5. And then from the top, we can think of it as 2x times 1, or we can think of it as 2 times x times 1. So, does the top and the bottom have any common factors? Yeah, 2. So we mark out the 2 from both the top and the bottom. So on top, we're just left with x, and on the bottom, we're left with x plus 5. Or I could write that as x over x plus 5. But what I can't do is I can't mark out the x's. Because again, we can only cancel common factors. Because you can think of the top as x times 1, and then the bottom would be 1 times the quantity x plus 5. Now they're written as factors. What factors do they have in common? Just the 1. So you can't mark out the x's. X and x plus 5 are not the same value. So you can't mark those out. Because if x was 4, x plus 5 would be 9. 4 over 9, you can't reduce that. So just because you have an x on top and an x on bottom, they're not always going to cancel. They have to be factors in order to cancel. So let's look at another one. Let's look at this. Y times the quantity y squared plus 6 over y squared. So before you start canceling stuff out, you always want to make sure everything is written as factors. Well, the top is already factored. This is just y times this quantity. You can think of the bottom as being factored too. You can think of it as 1 times y squared, or you can think of it as 1 times y times y. So what can we mark out here? Well, we have a y on top that will cancel with one of the y's on the bottom. So what's left over? On top, we just got y squared plus 6, and on the bottom, we just got a y left over. So that's reduced. And again, you can't cancel out this y here. You can't cancel this y with one of the y's up here. That doesn't work. Okay? Because you can only cancel factors. So if you were to factor the top, this would be 1 times y squared plus 6. And the bottom would be 1 times y. And the only thing that would cancel would be 1s, and you still end up with the same thing. So this is your answer. If I gave you a problem like this and asked you to factor it, you should be able to do it. Simplify it. X plus 3 over x. Well, we want to see if we can simplify this. So let's look at the numerator. Can I factor x plus 3? Is there a GCF? Nope. The only GCF is 1, so it's basically prime. So the only factors of x plus 3 are 1 times x plus 3. Can you factor the bottom? You can't. X is prime. The only factors of x is 1 times x. What cancels out? The 1s. So what happened? Nothing. This is the answer. So if you see a problem like this on today's assignment, you would write already simplified. Okay. All right, let's try a couple more. Let's do this problem. 2x plus 2 over 3x plus 3. Now again, before you start canceling things out, you got to make sure you always have everything factored first. Can the top be factored? Yes, we can factor out a 2. So we can rewrite the top as 2 times the quantity x plus 1. Can the bottom be factored? Yes, we can factor out a 3. 3 times the quantity x plus 1. So now we got both the top and the bottom written as factors. Do they have any factors in common? They both have the factor x plus 1. So the factor x plus 1 on top will mark out with the factor x plus 1 on the bottom. And our simplified answer would be just 2/3. All right, so let's try one more of these. Let's look at this one. 4x squared plus 8x over 5x plus 10. So again, don't just start marking things out. You can't just do that. You got to make sure everything is factored first before you start marking things out. Well, can the numerator be factored? Well, those two terms have a GCF. You can factor out a 4x. So you'll end up with getting 4x times the quantity x plus 2. On the bottom, what can you factor out of the bottom? A 5. So you end up with getting 5 times the quantity x plus 2. Now that you got both the top and the bottom of your fraction factored, now you can cancel out common factors. So they both have x plus 2. So the simplified answer would be 4x over 5. So the key to today's assignment, either you're going to have to factor out a GCF first and then reduce, or it will already be factored. I will have it already in factor form and you just cancel stuff out. So see what you can do. Got any questions, feel free to email me.